Okay, let's next talk about how to graph translations of these exponential functions. So if we shift it left, shift it right, shift it up, shift it down. So recall, we've actually already seen this type of translation. We had vertex form. So if you remember, we had a parabola, you'd have it factored with this guy hanging out. Remember, on the inside here with this guy, you would shift it left 3, and then you'd shift it down 4, right? The inside part with the x is the left and right horizontal shifts. So this would be left 3, it's the opposite kind of what you think, and this would be down 4. So for the parabola, it would go left 3, down 4, and then I'm just going to make a rough sketch here. It's positive, so it face up. So this, best parabola in the world. All right. Now we also did this with absolute value. Same thing. We have y equals negative absolute value of x minus 2 plus 1. Same thing. The guy hanging out on the inside represents the horizontal shift. It's kind of the opposite of what you think, so that's going to be to the right 2. And then on the outside is your vertical shift. That'd be up 1. And this negative means this is a reflection. A reflection over the x-axis. It's a reflection over the x-axis. So that would look like, again, you go to the right 2, boom, boom, you go up 1, and then it would be, instead of going up, it would be going down. Again, you reflect it over the x-axis, so it would be like over here, going down like this, going down like this. So we've already graphed these kind of translations with absolute value functions, parabolas. We're going to do the same thing now with exponential functions. So we've got this negative here. So just like it means for these guys, this negative means that it's going to be a reflection. It's going to be a reflection over the x-axis. But what you can do is you can graph the parent if you want. You can graph the parent. I'll do that in blue. The parent is y equals 5 to the x. Basically, the parent is the same guy without the little negative in front. Let's make a t-chart. So what would that look like? So negative 2, negative 1, 0, 1, 2. 5 to the negative 2 would be 1 over 5 squared, or 1/25. 5 to the negative 1 would be 1 over 5. 5 to the 0 is 1. 5 to the 1 is 5. 5 squared is 25. All right, so you can actually graph this parent first. So negative 2, I'll have these go by 1s here. And let's count these by 5. So 5, 10, 15, 20, 25, 30. So negative 2 goes to 1/25, so super, super small. Negative 1 goes to 1/5, again, super, super small. 0 goes to 1, so you're only really a fifth of the way up here. 1 goes to 5 up here, and 2 goes to 25 up here. That's the parent. And then we could draw that in. Exponential growth this way. Basically, this is, again, just going to be a reflection. It's going to be flipped over here. So all you're going to do for the negative is that the y is going to turn into a negative. So y equals negative 5 to the x. I'll do that in red. Negative 2 becomes negative 1/25. Negative 1 becomes negative 1/5. 0 becomes negative 1. 1 becomes negative 5, and 2 becomes negative 25. You don't really need to do the t-chart again, just doing that for effect. So negative 2 goes to the negative version, negative 1 goes to the negative version, 0 goes to the negative version, 1 goes to the negative 1, and 2 goes to negative 5, 10, 15, 20, 25. So it's the same thing, it's just a reflection over the x-axis. And really, this is the function we were asked to do. This is the function we care about. So you don't really need to graph the parent. Let's try one more with a different shift here. So number 2, why don't we graph y equals 1/2, and let's do x plus 1 minus 2. So let's plan what's going on here. So there's no negative, it's not reflected, but we've got this shift. And just like the other guys, when it's included with the x, just like these guys over here, here, and here, it's a horizontal shift. It's the opposite of what you think. So that's going to be a shift to the left 1. And this is going to be a shift down 2. So let's go ahead and make our little graph here. Leave some more room up top because we're not reflecting it. So let's make a t-chart. We'll do the parent first. Now the parent, we just take away all these extra numbers. y equals 1/2 to the x. Make a t-chart here. So -2, -1, 0, 1, 2. So -2, 1/2 to the -2. 1/2 to the -2 gives me 4. 1/2 to the -1 gives me 2. 0, so 1/2 to the 0 gives me 1. 1/2 to the 1 gives me 1/2. 1/2 squared gives me 1/4. So let's go ahead and graph this. -2. We got -1, -2. We'll make this just the normal 1, 2, 3, 4, 5. Actually, we just need to go for 4. 1 and 2. So -2 goes to 4. -1 goes to 2. 0 goes to 1. 1 goes to 1/2, and 2 goes to 1/4. So that's our parent function. Let's just go ahead and graph that. And hi, sweetie. And let's go ahead and do the shifting. So we'll just take each one of these dots. We don't even really have to think about the points. We're just going to shift it 1 to the left, 1 to the left, and we're going to go down 2. So let's start with this guy. So we're going to shift it 1 to the left, and then we're going to go down 2. And that's our new points. We'll go with this guy. We'll go 1 to the left. Well, just all the 1 to the left, 1 to the left, 1 to the left, 1 to the left. And we're going to go down 2. So this guy ends up at 0. This guy's going to end up at -1. This guy is going to be at negative, let's see, so here's a half, so down 1 and then an additional half. And this guy's at 1/4, so we're going to be, here's 1 1/4, so you're going to be down at negative points, that's a -3/4 right there. So let's go into our graph here. Sorry, the graph is kind of running out, but you get the picture. Same type of shape. Now the difference here, let's go ahead and draw this in. So it's -1 3/4. As we get closer and closer, our asymptote is y equals -2. Y equals -2. Why is that? It's because we shifted everything down 2. So instead of being y equals 0, our asymptote is all the way down here.